Hey guys, I have notes here for section 6.5. This will be the last set of notes in chapter 6. And what I'm going to show you is we're kind of going back to the beginning of the chapter when you did area under a curve using rectangles. And I showed you how to do left corners, right corners, and midpoints, rectangles only. Well, now I want to show you another way. It's even better. And we're going to use trapezoids instead. We're going to use trapezoids instead of rectangles. So you can see I've got area under the curve. I've divided it into 4 parts. So I'll show you the area using 4 different trapezoids. Now, quick review of geometry. Might have been a while since you've used area of a trapezoid. So keep in mind, a trapezoid is simply a quadrilateral with one pair of parallel sides. Now, often when you think of a trapezoid, you often think of an isosceles trapezoid where these are parallel and then it comes down like this, kind of like an isosceles triangle with the top chopped off. Well, yeah, that's a isosceles trapezoid. I'm drawing a right trapezoid where I do have a pair of parallel lines, but I have a right angle here. So what's cool about this is the segment that joins this base with this base is actually the height of the trapezoid. I don't have to do some funky dotted line kind of throughout the middle of the trapezoid. My height is already there. So it's a right trapezoid. That's the height of the trapezoid. This is called base 1. This is called base 2. This is kind of irrelevant when it comes to, the length of this is kind of irrelevant when it comes to finding the area of a trapezoid. So the formula is 1/2 times the height times these 2 bases lengths added together. Okie doke. Now, what we're going to do is we're going to take this trapezoid and I'm going to tip it up so that it's actually sitting on its height. But the two bases, we're still going to call them bases. I'm still going to call this the height, even though it's going to be resting on it. And my bases are going to be like kind of walls that are built up. And this is kind of like a rooftop. So here we go. I've sectioned my area off into 4 regions. I've drawn the walls. So I've drawn B1 and B2 for each trapezoid. Now I need to go through and put on the rooftops. Do you see how even with only 4 trapezoids, there's not much of a discrepancy for this function, finding the area, even just using 4. So it's going to be a decent approximation. Alrighty, so in trapezoid number 1, trapezoid number 1, trapezoid number 2, number 3, number 4. I got 4 trapezoids. The way, those are H's if you can't tell. I wrote them sideways and they look terrible, but that's an H, that's an H, that's an H, that's an H. This is the height for each trapezoid. Do you agree that the height is the same for each trapezoid all the way across? Of course it is. That's the way I chose to divide it. I chose to divide it into 4 equal parts. So the height's the same. All right, so here I go. I'm going to start my area for all 4 trapezoids. I'm going to label it with a capital T and a 4, claiming that I'm doing the trapezoidal method and using 4 of them. Here I go. 1/2 goes for the whole thing. So I got 1/2 times height times B1 plus B2. So since 1/2 is the same throughout, I just put it here on the outside. Now, for trapezoid number 1, the height is delta x times the quantity. I need this base, it's the y value that I get by subbing that in, plus this base. It's the y that I get from subbing that in. Plus 1/2 times delta x times b1, the y that I get from subbing that in, plus b2. Lost the plus sign. Hold up. Okay, so the y I get from subbing that in, the y I get from subbing that in. Third trapezoid. 1, 2, 3. Third trapezoid. The y that I get from subbing this one in plus the y that I get from subbing this one in. Fourth trapezoid. Height. The 1/2 is distributed, remember. The y that I get from subbing this one in, the y that I get from subbing this one in. Okay, you with me? So each trapezoid has its own height and its own two distinct bases. This trapezoid has this base and this base. This trapezoid has this base and this base. Now, do you see how trapezoids 1 and 2 share a base? B2 for 1, trapezoid 1, is the same as B1 for trapezoid 2. This one, however, is used only for trapezoid 1. This one is only used for trapezoid 4. But this one is a shared base. This one is a shared base. This one is a shared base. And you can see them repeated down here. This is only used once. X sub 1 is used twice. X sub 2 is used twice. X sub 3 is used twice. X sub 4 is only used once. So, as long as these intervals are the same, now, if you're going to divide them up, you're going to divide them up so that they're the same, but sometimes they're already divided for you, and they're not the same. If they're already divided for you and your heights are different, you have to make this huge, long equation. You have to write the area for each individual trapezoid. You have to. If this is different every single time, you've got to set up the area for all 4 trapezoids. But if this is the same, you can pull this out to the front and say, I need this base once, I need this one twice, this one twice, this one twice, and this one only once. One more time. If this is the same, you may shorten it a bit and say, I need one of these, two of these, two of these, two of these, and one of these. If they're different, you've got to write out the huge, long equation, and you've got to do the area for each individual trapezoid. Alrighty, we're trying one. So it says, okay, let's use 4. Trapezoid, use 4. We're going to estimate the area under x squared, and we're doing it from 1 to 2 this time. So I drew a picture. It's always good to draw a picture. If you're going to use 4 trapezoids, I would assume that you're going to divide this evenly. And each little delta x, each little height of your trapezoid is going to be 1/4. Now I'm going to go through and put the rooftops on. Let's see. So, rooftop, 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 rooftop. Trapezoid 1 has this height and these 2 bases. This trapezoid height, these 2 bases. These 2 bases, these 2 bases. So here we go. I'm labeling it correctly. Capital T with a 4, 1/2 times the height. It's going to be the same for every single one of them. And since it's the same, I can use I can use x equals 1, sub it in, and find that y value, and use that y value once. The next x that I sub in is 1 1/4. And whatever I get out of that, I'm going to use that y value twice. I thought about reducing this, but it's gonna allow me to have common denominators down here. So I kept this 6/4. So sub that in, use that y value twice. 7/4, we're going to use that y value twice. And sub in 2, that's the last one, we're going to use that one once. Okay, everything's the same except I did the math. I subbed in 1, I got 1. I subbed in this, I got 25/16. Sub that in, sub that in, sub that in. And then everything else I did without a calculator. It's totally doable. Got a common denominator here. And then before multiplying, I would totally reduce. Let's see, 4, 160. Now it looks like the biggest thing that goes in is 2. So I would take that down by 2 and that down by 2. And there you go. Alrighty. On the back, we have some data in a table. And looks like let's see, this is every hour. So at time 0, the temperature was 63, I assume, degrees. After 1 hour, 2 hours, 3 hours, and so on, 12 hours. This is asking for the average y value. What's the average on this function? Find the average on the function. And I am 99% sure if you take all of these values, add them together, and divide by 13, we're not going to get the same answer. Somebody's going to try it. Average value. We're going to do the integral divided by the interval to get the average value on this function. So how do you get, so I've got this. Problem is I don't have a function to put here to do the math on. All I have is a table of data. I don't have a function to do an antiderivative to sub those in. Well, here's what this is saying though. If you know anything about integrals, one of the things that this integral says is find the area under this curve. Take all the y values, find the area under the curve. Well, the best way I think to do that at this point is by using trapezoids. So we're still going to have this out in the front, but we're going to have our 1/2 times the height of each trapezoid. That's our integral. Times b1 plus b2 plus b1 plus b2 plus b1 plus b2 plus b1 plus b2 plus b, you know? So this is how I've set it up. The 1/12 came from here. The 1/2 is in the area formula for a trapezoid. The height of each trapezoid is 1. It's delta x. Use this y value once. Use all of these twice. And use the last one once. How do I know I can do it the short way? That was the same interval throughout. And I got the answer, and I just wrote it 3 ways: as a fraction, as a repeating decimal, and as a decimal rounded to 3 decimal places. All right, have fun making those trapezoids.